Okay, so today we're going to do the Chapter 7 study guide. You will be allowed to use this on the exam this Friday. So your Chapter 7 exam is this Friday. I believe it's the 18th. Okay, so this means also that any late work that you have that you want to get full credit for, you need to get that to me before class on Friday, okay? So coming into class Friday, that's the last time you'll be able to tell me if you made up any late work for Chapter 7, which is just last week and this week, so we did it pretty quickly. Anything after your class today will only be, not today. Anything after your class period on Friday will be worth half credit, okay? So this first page, I believe, is mostly just definitions. You can read through like what exactly you were expected to learn. Tomorrow, you guys will have your Chapter 7 EST, which is the Essential Skills Test. And then we'll do retakes on Thursday. So tomorrow is Wednesday 3-16-22. Okay? All right, so let's see here. So this goes over positive association. It's when one variable increases and the other increases as well. So it's going to look something like this, okay, like this graph here. That's an example of a positive. This one's also an example of a positive. It's relatively weak, but it is still an example of a positive association. And then a negative association means when one variable increases, like the x variable increases, then the y variable would be decreasing. And that's going to look something like this graph here. And these two down here as well. Okay? And whenever there's no association, which I don't think there's actually a picture here for that, but no association, we did take notes on all of these, so I'll draw like a little one here. It's basically like your data is all over the place, and the two variables you're looking at do not affect the other. So something like the size of my shoe and my grades in school. Those two things have nothing to do with the other, so there would be no association. The form, you could have a nonlinear type of graph, like this one here. This kind of goes like this. This is called an exponential. You'll learn a little bit about that in Integrated Math 1. But this is an example of something that is non-linear, and then this one to the left is linear, okay? So like even down here, these are all pretty linear. I mean, yes, this one has a super weak association, but there's nothing up here and there's nothing down here, so you can kind of see that there is still a linear association there, okay? So the strength means like how close all the data is to the line of best fit. So you can see that the data gets more and more spread out the weaker the strength of the scatter plot is. Now an outlier would be like if I had something way up here. That would be an outlier, or something way down here. And then for the weak positive association, it's a little bit difficult. The outlier would have to be like way outside, you know, from the data to be considered an outlier. I thought if I got up and drank coffee, I would not yawn during this, but I guess I was wrong. Alright, so here's an association practice problem. So what we need to do is plot those points on our graph, but let's read the problem here. So it says, Marissa's older sister was discussing purchasing a car with her summer job earnings. Marissa collected data from her friends at her job. Marissa wants to convince her dad that newer cars are more fuel efficient, meaning that they don't need as much gas, they're able to go further, they have a greater miles per gallon. So we're going to make a scatter plot of the data. It looks like we're looking at age of car as our x variable, and then average miles per gallon as our y variable, because we're trying to see if the miles per gallon depends on the age of the car. So here I'm going to put average miles per gallon. You guys might see that written as MPG. And then here would be the age of the car. How old it is. Okay. So right here it says draw a line of best fit to the data, but I'm just going to jot down right here. Our dependent variable was the average miles per gallon. Our independent is the age of the car. We're trying to see if the average miles depends on the age of the car, average miles per gallon. So I'm just going to put average MPG. AVG means average. All right, so our first point here, I'm looking up here, we have 9,34. So the car was 9 years old and it got about 34 miles per gallon. So you guys could always use like a ruler, you know, to help you plot the points. I'm just going to try to eyeball it the best I can. 2-year-old car, 30 miles per gallon. So 2 years, let's go up to 30, which will be in between 28 and 32. Oh, and then we have a 5-year-old car that also gets 30 miles per gallon. And then we have a 1-year-old car that gets 35 miles per gallon, so it's going to be right there. 4-year-old car gets 34 miles per gallon. A 10-year-old car that gets 28 miles per gallon. 9-year-old car that gets 27 miles per gallon. A 3-year-old car that gets 40 miles per gallon. And an 8-year-old car that gets 29 miles per gallon. So you guys see here too is they didn't specify what kind of car they're looking at, right? So in this case, it almost looks like it has a negative association, right? So let's see here. You can see, it's a little difficult to see right now, but you can see how the data does trend downward, okay? So your line of best fit, let me see here if it lets me kind of move it, yeah. Your line of best fit could be anything like this, okay? Something like that. Because I'm trying to balance it, because even though these are still way up here, right? I'm trying to get closer to all the data that's here as well. So we do see a trend. What this trend is telling us is the older the car gets, the less miles per gallon it gets, which means older cars are less fuel efficient. So she was right. She was saying that the older cars are less fuel efficient. Now, like I said earlier, like I wonder if they're looking at a specific type of car, because I know they definitely still make cars that are not very fuel efficient, but I wonder if that fell into play. But in our case, it did not. So on your exam, you're going to be asked to write the equation of a scatter plot line of best fit. So what you would want to do here, I'm going to write it up here. Find the equation of your line of best fit. So y equals mx plus b. Okay? B is our y-intercept. So you want to look at wherever your line is. And I see it's right there at about 37. So I know I'm going to write 37 here. And we all might come up with slightly different lines. That's okay. All right, that is fine. M is our slope. Okay, so M is our slope. So what I'm going to do is I'm going to find some lattice points. I'm going to use the y-intercept. Whoops. I'm going to use the y-intercept here. And I see another lattice point right about here. But really anything that you can find you can use. So I'm just going to draw a slope triangle here. Okay. Now be careful with these because I have to remember how the x and y-axis are labeled. The y-axis does go by ones, so my rise over run the rise, since it goes by ones, I went down 1, 2, 3. Okay, so -3 over, and then down here we skip every 4, and that's 1, 2, 3. Huh, interesting. So -3 over 3, and you might not get exactly that, right? It's okay if you don't. But I get about -1. So for my slope, I'm going to say -1. So y equals -1x plus 37. Okay? So here it says, use the equation to predict what the correct mileage for a 7-year-old car should be. So what we said up here was that the x is the age of the car. So this x value here is how old the car is. So if our line's equation is, oh, whoops, I forgot to write up here. Slope, we got -1. The y-intercept, we got 37 for the line that I drew. So here, -1x plus 37, and if x is the year of car, right, so the age of the car, then I'm going to replace x with 7, 7-year-old car. So y equals -1 times 7 plus 37. Y equals -1 times 7 is -7 plus 37 equals 30 miles per gallon. And this is an estimation because we used our line of best fit, okay? So line of best fit gives us estimations. I'm going to write that here. Line of best fit gives us estimations. It's not perfect, right? It is just the best fit of the data. So it gives us estimations. So looking at this association here, is our line positive or negative? This one is negative. It's going down from left to right. Is it linear or nonlinear? The fact that we can draw a line of best fit means it is linear. Is it strong or weak? I would say this one is like moderate to weak. It's definitely not strong data, but it's kind of moderate to weak data, is what I would say. One might argue that like this guy way up here is an outlier, but not really. I mean, like that fits the data. It's a younger car, only 3 years old, and it gets 40 miles per gallon. So even though like these younger cars than 3 years old get less miles per gallon, this guy still meets the data. If we had something that was like way down here, like a newer car getting 16 miles per gallon, then that would be an outlier for sure, definitely. Or if we had like a super duper old car up here that gets really high miles per gallon, that would be an outlier. But here I would say no, there's no outliers here. Okay, so pause the video if you need to, make sure you get all that down. All right, you guys have probably seen this little setup before. So M is your slope. The ratio slope is rise over run. B is your y-intercept, where it crosses the y-axis. It's whenever x equals 0, so your y-intercept is 0, comma b. Whatever b is, that's the number that would go there. Okay? So we are going to answer some questions about slope-intercept form. So here it says, what is the slope of the line? Here's what I'll do. I'm just going to keep bringing this down. Whoops. Copy. Paste image. There we go. All right, so I always like to find the y-intercept first, honestly. So my y-intercept is right here at 10. So my y-intercept is 10. So I could even write plus 10 here. to start off my y equals mx plus b. Now the slope, oh, I just realized I used the wrong colors. Hold on, it's going to bother me. So I said y-intercept is 10 plus 10, 10, right here. So now your slope, you have to create a slope triangle. I see I have a lattice point here and one here, so I could use any of these 3 points I have here. A lot of students tend to just start from the y-intercept and use that. So my rise over run, my rise here, I'm going up 5 because look, it goes 5, 10, 15, 20, 25. So that means I'm going up by 5 every time. So my rise is 5, and the run on the bottom, I just go by ones, so it's 1, 2. So 5 over 2. Now I cannot divide top or bottom by anything. You could get 2.5 if you divided it, but honestly, just leave slopes as a fraction if it's completely simplified. And don't forget to put your x next to your slope. So this graph would be y equals 5/2 x plus 10. Make sure you pause if you need to, because I'm going at a decent speed here. Now I need to look at all the rest of this real quick. Okay, cool. I'm going to start to go pretty fast because I want you guys to use this to check your answers. So please try the problems first, and then you can check your answers, okay? So I'm going to go through it, obviously, so you guys can check your answers. So this y-intercept here, I notice it's going like -1, -2, -3, -4, -5. So this one is -2. Or we could write it in terms of, you know, a point, which would be more accurate, even up here too. I probably should have done that, because you might see that as your multiple choice. It's 0, 10, 0, -2, because it's where x equals 0. So now for the slope triangle, I see I have lattice points here. So it doesn't matter which one you use, totally up to you. I'm going to use this one and then the one here on the x-axis. So it looks like up here they also go by ones, so that's helpful to know. So my rise here, my rise was a 2, and then I ran over 4. So slope is rise over run, 2 over 4, and I'm going up, so it's positive. Oh, I know that these two can both be divided by 2, so then I get 1/2. So my slope is going to be 1/2, which makes my equation y equals 1/2 x minus 2. Okay. Now I want you to do this one on your own. Okay, so do this one on your own. Since I just gave you a good example, I will just mark some points here for you that might be able to help you out. So some lattice points are here and here. Okay, so do on your own. And then I'll do one of these negatives here. Okay, so I see here that there's a y-intercept at 2, because these go 1, 2, 3, 4, 5. And even the x-axis is going by ones as well. So then if I need to find, so here 0, 2 is my y-intercept, and then I need to find other lattice points here. So a lattice point could be right here, or even right here as well. Now I need to make a slope triangle. So I can use any 2 of the lattice points, including the y-intercept. That is also a lattice point. So we're definitely going down this time. It's a negative. So we go down and then to the right. So my slope is rise over run. I went down 1, 2, 3, 4. And I went over 1. So my rise was a -4 because I went down over 1 for the run. Okay, so -4 divided by 1 is -4. So my equation here will be y equals -4 x plus 2 for my y-intercept. Now this one over here again, I will give you some lattice points that you can use. And then I see this one here, but you definitely have to know how to find lattice points on your own. If you don't, please ask me. But this one again, do on your own. You should be able to use my notes to help you. The smiley face looks kind of evil. Let me fix its eyes. There we go. All right. So let's see here. These are definitely what I wanted to get to, the proportions. So we did this back in chapter 1 and a little bit more throughout the first semester. So here we have Ryan and Janelle are driving from different locations to meet at Mammoth Lakes. I really want to go snowboarding there one day. When they each stopped for lunch, they called each other on their cell phones. Ryan had traveled 245 miles in 3.5 hours. So Ryan had traveled 245 miles in 3.5 hours. And Janelle had driven 260 miles in 4 hours. How fast was each person driving? Give their speed in miles per hour. So this is otherwise known as the unit rate. Okay. So we're going to set up for Ryan and for Janelle. And if it's miles per hour, that means it wants the miles on top and the hour on the bottom, because we want it to be worth 1 hour. So Ryan, he traveled 245 miles in 3.5 hours. Now, if you divide this, this will give you how many miles he traveled in 1 hour. So let me see if I can find my calculator. Oh, there it is. So it was 245 divided by 35, right? 7. 245 divided by 35, let me make sure. Oh, divided by 3.5, my bad. Hold on. 3.5. 70, okay? So he's going pretty fast, honestly. So that kind of relates, or that does relate directly to how fast you're going in the car. So he went 70 miles in 1 hour. So that would be 70 miles per hour. Now, Janelle here, Janelle had driven 260 miles in 4 hours. Now we're going to see who went faster. Okay. So 260 divided by 4 is 65 miles per hour. And that would just, you can rewrite it as 65 miles per hour, like that. So who went faster was Ryan. It didn't ask who went faster, but how fast was each person driving? This is how fast they were each driving. Ryan was going 70 miles per hour, and Janelle was going 65 miles per hour. Okay. So now it says here, if Janelle originally started 575 miles from Mammoth Lakes and continues traveling at the same rate, how many more hours will it take her to arrive at Mammoth Lakes? Okay. So what we can do here is, if we know that she travels 65 miles in 1 hour, so this is about Janelle. So she travels 65 miles per hour. And she originally started 575 miles away, and she's already traveled 260. So I'm going to subtract that. Get 513. 315 miles left to go. Okay? So what we can do here is we can set up a ratio. If we know she can drive 65 miles in 1 hour, and we have 315 miles left. We want to know how long it takes her, how many more hours it'll take her to drive those miles. You could have also set up 260 over 4 equals 315 over x. You would have still had to subtract it, but that would have helped you with finding that as well. So here we can cross multiply to solve this. So 1 times 315 is 315. And 65 times x is 65x. So now we must solve for x. We want to divide both sides by 65. So we get x equals, let's see what we get, 315. 315 divided by 65. It's about 4.85 hours, sorry, goodness. 4.85 hours left. Put a little squiggly because it's about that much, okay? So you guys might have to set up proportions where you have to cross multiply, and we will practice that on Khan Academy. That's something else you're going to see on your test on Friday. So here it says tell whether there is positive association, negative association, or no association. The number of inches of rain per hour and the height of water in a reservoir. This one, please try on your own because you're going to have to do this on your test, okay? And this is going to give you the answers to check it. So pause the video. The first one would be positive. The level of water in a reservoir will rise as more rain drops. The amount of food a person eats and how many pets he or she has. No association. You can just write it like that. Association for short. The height of a tree and the amount of nutrients it gets. I would say the taller the tree gets, it means it's getting more and more nutrients, right? So this would be a positive. The number of hours spent hiking in the mountains and the amount of water left in your water bottle. Well, the longer you spend hiking, you're probably going to drink more water. So the amount left in your water bowl will, I was looking at my dogs. Your water bottle will decrease, right? Because you're going to drink your water, so you won't have as much. So this is a negative association, okay? So please make sure you ask me any questions and that you complete all problems, especially those ones that I said please do on your own, okay? Have a great day.